Hello student, today we are going to discuss the fourth numerical of alum as coagulant. Question will be given as a water treatment plant treating 10 mld of water. It means that discharge is given as 10 mld. Requires 20 milligram per liter of filter alum. It means that alum dose is given as 20 milligram per liter. Now determine the total alkalinity requirement in 10 to the power 6 milligram per day as CaCO3 matching filter alum. Okay. Now firstly we need to calculate the amount of alum required in milligram per day. Okay. Firstly we will need to calculate the amount of alum required in milligram per day. Okay. Now the alum dose will be given as 20 milligram per liter. Alum dose will be given as 20 milligram per liter and the discharge is given as 10 mld. Okay, 10 mld. Now we just need to multiply here for the calculation of alum on per day basis. We just need to multiply here the alum dose with the total discharge, that is 10 into 10 to the power 6 liter per day. Now from liter to liter cancel out, it will comes out as 200 into 10 to the power 6 milligram per day. Okay. Now we know that 1 mole of alum generally requires 3 moles of calcium bicarbonate. We all know that 1 mole of alum generally requires 3 moles of calcium bicarbonate. Now, for the calcium bicarbonate production, we need calcium carbonate. So, when calcium carbonate reacts with water and carbon dioxide, it will form what? Calcium bicarbonate. Correct? Now, 1 mole of calcium carbonate require 1 mole. Okay, 1 mole of calcium bicarbonate formation, 1 mole of calcium carbonate will be required. Okay. Now, for the 3 moles of calcium bicarbonate formation, how much moles of calcium carbonate will be required? It means that for 1 mole of alum, if 3 moles of calcium bicarbonate will be required, now we need to form the 3 moles of calcium bicarbonate. For 3 moles of calcium bicarbonate, we require 3 moles of calcium carbonate. Clear? Now 1 mole of alum generally weighs 666 gram. Okay. It will be equals to 3 into 100 gram of calcium carbonate. Now we need to calculate for 200 into 10 to the power 6 milligram per day. 200 into 10 to the power 6 milligram per day alum, for which the CaCO3 required will be 3 into 100 divided by 666 into 200 into 10 to the power 6 milligram per day CaCO3. Now if you solve all these values, that is 3 into 100 into 200 divided by 666, it will comes out as 90 into 10 to the power 6 milligram per day CaCO3. So they had asked the answer in 10 to the power 6 milligram per day. So the correct answer will be 90 milligram, 90 into 10 to the power 6 milligram per day as CaCO3, which will be the complete solution of this question. Clear to all? Okay, done. Thank you very much.